Hey everybody, we're back for some more algebra. Hope that came out, please God. But if you didn't hear it, was algebra. Okay, this is for the higher tier students only. The foundation ones are going to continue working through some examples, give you a good lot of weeks practice, and you'll all be experts by the end of it, which will be fabulous. But for the higher ones, I'm going to keep layering it on. This week we're doing factorising expressions, but starting with multiplying out brackets, which I know an awful lot of you could do in the class, but I'm going to try and make it even harder for you. Why not? Why shouldn't we do that? And then following weeks we'll do things like changing the subject to the formula, which you'll really hate me for because an awful lot of that's about feeling how to do it from just practice examples. We'll do quadratic equations, we will do simultaneous equations, and that should take us up to Christmas. Fingers crossed. So, what we'll start with here. We're going to start with multiplying or expanding brackets. Right, consider the example 3 multiplied by a plus 5, or 3 bracket a plus 5, or as I would say it, 3 upon a plus 5. If you think back to BODMAS, we have to deal with the brackets first before we do anything else. So if that had been, the a had been a 1, you would have done 1 plus 5 first, and then multiplied by the 3. You'd go to 18. But as you know, we can't add the a and the 5 together because they're kind of, one's letters, one numbers, doesn't make any sense. So think about what that actually means. It means add 5 to a, then multiply the whole lot by 3. Right? Or 3 lots of a plus 5. Or 3 lots of a added to 3 lots of 5. So if I visually look at it, 3 lots of a plus 5, well there's 1a plus 5, and the a is represented by an absolutely beautiful sun because we are getting none of it at the moment. There's another a plus 5, and there's another a plus 5. And if you look at those, if we were to add those together, we would group our a's together, and that would be a plus a plus a. That would be 3a, and then with 5 plus 5 plus 5 be 15. And as you can see, that's really 3 times the first term, 3 times the second term. So the number outside the bracket multiplied by the first term, added to the number outside the bracket multiplied by the second term. Let's look at another example. This time we'll do it in reverse. We'll see what it looks like when we get the answer. So 6 upon 2a plus 4, that's 6 times 2a added to 6 times 4, which gives you 12a plus 24. 6 times 2a gives you 12a, 6 times 4 gives you 24. And if I look to see what that looks like visually, it's 6 lots of 2a plus 4. The a's are represented by these resplendent rainbows. Just, amazing. Yeah. One thing that annoys me about rainbows, do you know the song you learned when you were at school? Red and orange and pink and green. That one? Those aren't the colours in the rainbow. That really annoys me. See as you learn what the colours in the rainbow are. I don't know. Really messes my OCD. Just a bit of a side. Do you know what the colours of the rainbow are? I do. Anyway. So, there's an 2a plus 4, 2a plus 4, 2a plus 4, 2a plus 4. There you go. If you can see there are going to be 12 rainbows, and if you add up all your numbers together, you'll get 24. So, bear in mind, rainbows is pretty much one of the only things I can remember from science in school. Don't know, maybe who knows? Who knows? Let's look at an example without using rainbows and suns. Well, 5 upon 2z minus 3. So we do 5 times the 2z and 5 times the minus 3. Gotta be careful of your signs. Okay, so you do 5 times your 2z and 5 times your minus 3. If I do that, I will get 10z here, and the 5 times 3 gives me 15. With a plus and a minus, that gives a minus, we get 10z minus 15. Easy enough. What about this if I make it a little bit harder? So I have 2 sets of brackets, and I have to deal with both of them separately. So I'll have to do 2 times 3p here, plus added to 2 times 4, and 3 times 4p added to 3 times 1, which is the second bracket. I'll multiply each of these out separately. So with 2 times 3p will give me 6p, with 2 times 4 will give me 8, with 3 times 4p will give me 12p, and with 3 times 1 will give me 3. If I group those together, I get 18p plus 11. And nearly a negative sign was seen. Let's have a look at some examples for you. So you can pause the video. I'm going to give you the answers in a second. Put them up and away we go. Okay, you've tried them. Let's see what you got. First one is 7n minus 21. 7 times n is 7n, and plus 7 times minus 3 is minus 21. Next one, 4 times 2x is 8x. plus 4 times minus 3 is minus 12. Last but not least, p times q is pq, and p times minus 2p is minus 2p squared. There's a Shakespeare joke in there somewhere. I'm just going to leave it out there. You can probably make it yourself. What about the next ones? 5 upon 2y minus 3 is going to be 10y minus 15. 5 times 2y is 10y. 5 times minus 3 is minus 15. And last but not least, with x times 2x is 2x squared plus x times y, which is xy. Dead easy. What about some of the harder ones? Okay, pause. And I'm going to give you the results. So 4 times x gives us 4x. 4 times 5 is plus 20. Plus 3 times x is plus 3x. And plus 3 times minus 21, or minus 7 is minus 21. If I group those together, I get 4x plus 3x give me 7x. Plus 20 minus 21 is minus 1. And last but not least, we get 5 times 3p is 15p. 5 times 2 is 10. Minus 2 times 5p is minus 10p. And the bit that will always catch everybody out, and there's nearly always one in the exam because they do it like that, because the bit that catches everybody out is minus 2 times minus 3 is plus 6. If you look at any examiner's report of the ones on the site, on the AKI site, you'll see it's always done wrong. It's the reason they put it in the exam every time, because it catches people out. It's the weird one. People always just do the 2 times the minus 3 and they get minus 6, but that's not right. So here we have 15p minus 10p, which is 5p. Plus 10, plus 6, plus 16. Bravo. Next. Factors. What's a factor? Dum dum dum. I feel like it should have like a scary music in the bit between subjects here. So factors are terms that make up bigger terms, and we did these last year when we're studying. You would normally have thought of these as numbers, but that is not always true. I'll leave the ones with letters to a wee bit later in the video here, but otherwise, you know, you would normally thought of them as letters. So if I asked you for the factors of 24, well, these are the numbers which you can multiply together to give you 24. So if I ask you to make a list, you'd probably say something like this, and you'd probably put them together, group them together. You'd probably say 8 and 3. 8 3s give me 24, and you'd be right. If you'd have said 6 4s, you'd also be right. If you said 364 and 19, you'd have been wrong. But if you'd have said 12 and 2, you'd have been right. And the ones that everybody forgets, 24 and 21, you'd have been right as well. Okay? Hopefully you all got those, but that's classically how we made our factors before. And if you think back to last year with chickens and with dictionaries, one of the first exercises I got you to do at the start of the year was the chicken and the dictionary. To get you to think of numbers made up of other numbers and how that follows through. Factors in algebra. These can include letters as well as numbers. So 2 is a factor of 4. That's not be blown anybody's mind so far. But 2 is also a factor of 6x, because 2 times 3x gives me 6x. So 2 is a common factor of both 4 and 6x. And we did common factors last year, but most normally we did half common factors. So we worked out all the factors of two numbers and then find the half one that was in both lists. But all those other ones that they have in common are called common factors. Let's take an example. So which of these terms have an x as a factor? And the second part of that, if it has x as a factor, write each term from part A as x times a number or x times a term. So what does 6t? Does it have an x? It doesn't. It has a 6 and it has a t. It has no x. What about 4x? It has an x. And it's 4 times x. X squared has an x and it's x times x. It's got more than one x, but it definitely has x as a factor. 10 has no x. And xy has x as a factor, and they are written as x times y. And there are your answers. And I apologise for yawning again. My daughter was up being sick last night and had to sleep in her bed, and having to sleep with 16 princess dolls, it's an awful lot harder than you would imagine. If it had happened to me when I was about 4 or 5 years of age, things could have been very different in my life, but it is what it is. Factorising an expression. Factorising an algebraic expression is the opposite of expanded brackets. So we're trying to get an expression and put it into brackets. And you might say, why on earth, God's earth, would you want to do that? Well, there are reasons for it. And unfortunately, the answers to those lie usually in the last 3 questions of a paper, because it's usually done. They usually come in handy there. But we'll See how we get to when see how we're dealing with that when we see those, when we're going through all the past papers, which will be great fun. I'm sure you'll agree. So I'm going to start off by holding your hand a little bit through it. So copy and complete these. We've got 3t plus 15, and we've got to put it in the brackets. And in this case, what you're really looking to do is divide both terms by 3. If we've got 3 outside the bracket, we want to divide both terms by 3. So 3t divided by 3, 3's cancelled, you're just left with t. Same as 15 divided by 3 gives me the 5. So you've got 3 upon t plus 5. And secondly, what do we need to divide both terms by so that we end up with n plus 3? Well, 4n divided by what gives me n? 4n divided by 4 gives me n. And we can check that. The 12 divided by 4 also gives us 3. And it does. And there are our answers. Oops, there's the answers to these ones. So 5 upon a plus 20 is 5 upon a plus 4. 4x minus 12 is 4 upon x minus 3. And if I use x, both of these terms have x as a factor. So I take x outside, divide that by x, I'm left with x. Divide that by x, I'm just got 7. And that is factorization. Shortish video this week, which is great. But we'll just keep on layering it on the top of the stuff we did last week. We'll use these in conjunction with solving equations. We'll see how you go. And then we'll put a bit more scary stuff on next week. We'll keep working away on it. We'll keep working away on it over the year. And hopefully, by the end of it, we'll come out all sparkly and nice. And we'll all have super grades. So until next week, I'll catch you then. Bye.
Moving at the speed of light into eternity. Yeah, tonight is the night. Come join me in the middle of ecstasy. Feel the melody and the rhythm of the music around you, around you. Yeah, I'ma take you there. I'ma take you there. So don't be scared, I'm right here, baby. We can go anywhere, go anywhere. for a girl